So for this lesson, we're going to be doing trig values of any angle. So to start, we're going to talk about where each trig value is positive and where each trig value is negative. So I am going to construct just a coordinate plane and draw a triangle in each quadrant and talk about what is happening at each quadrant. So we talked about how the hypotenuse is always positive. So these are always going to be positive. And then we talked about how this is part of the positive y-axis, so that leg is always positive. This is part of the positive x-axis, so that leg is always positive. This is part of the negative y-axis, or it falls in the negative y-axis, so that is negative. This is sitting on the negative x-axis, so that leg is negative. This is in the positive y, and this is in the negative y. Okay, so if we use our reference angle and we're to evaluate, let's just start with sine and cosecant. If I were to start in the first quadrant and I were to evaluate something, and sine and cosecant go together because whatever the ratio is for sine, it's just the reciprocal for cosecant. So if I were to do opposite over hypotenuse, I would generate a positive over a positive ratio, so that is positive. When I move to the second quadrant, if I were to evaluate a trig function or sine function here, it would be a positive over a positive, so it would also remain positive in the second quadrant. As I go to the third, opposite over hypotenuse, that's negative over positive, which would be a negative ratio. And then in the fourth quadrant, opposite over hypotenuse, that's a negative over a positive, so that is negative. So looking here, sine is always going to be positive in the first two quadrants and is always going to be negative in the third and fourth quadrant. Moving on to cosine and secant. Again, since those are reciprocal functions, the signs will be the same. In the first quadrant, if you notice, all the side lengths are positive. So no matter what your trig function is, it will always be positive in the first quadrant. As I move to the second quadrant, adjacent over hypotenuse, that's negative over positive, so that is negative. In the third quadrant, adjacent over hypotenuse, negative over positive, also negative. In the fourth quadrant, adjacent over hypotenuse, that's positive over positive, so it is positive. So cosine is always going to be positive in the first and fourth and will always be negative in the second and third. Okay, the last two to talk about, tan and cotangent. Again, everything is positive in the first quadrant. All side lengths are positive. Moving to the second quadrant, opposite over adjacent, positive over negative will generate a negative ratio. Opposite over adjacent, negative over negative will become positive. That will simplify to something positive. Opposite over adjacent, that will be negative. So looking at this, we can see that tan is positive in the first and third and negative in the second and fourth. And so if we think about how sine is always positive in these first two quadrants, well, that's because that's where y is positive. And here's where cosine is, that's where x is always positive. And when we think about with like quadrantals, cosine is x over r. And then here, this is where x and y have the same sign. And so since those go together. Okay, so just kind of setting the foundation for the lesson today. Determine the quadrants that satisfy the following. So we're given some inequalities. So I'm just going to draw a coordinate plane. Here this says, where is cosine less than 0? That means where is cosine negative? So we would know that cosine is negative here and here, right? That's where it's positive, so that's where it's negative. So this is negative in the second and third quadrant. Where is cosecant less than 0 and secant less than 0? So this is where it's negative and where it's negative. So let's start with this first piece. Where is cosecant negative? So we can also think, where is sine negative? Sine is negative in the third and fourth quadrant. Where is secant negative, or where is cosine negative? Cosine is negative in the second and the third quadrant. So where are both of these happening since it says and? The third quadrant. Okay, then we're looking at cotangent is greater than 0 and sine is greater than 0. So cotangent, we can also think tan, that's the first and third. Sine is greater than 0, that's first and second. The only place both these are happening is the first quadrant. Okay. Number 4 says, if secant x is 3/2 and sine x is less than 0, find the following. Okay, so before I start looking at this questions they're asking me, I'm going to use this information. I first have to determine where I'm going to construct a triangle with this ratio, but where am I going to place this triangle? It's going to fall in one quadrant. So here secant is equal to a positive ratio. So where is secant positive? Or where is cosine positive? And then, well, it's two places. I need to narrow it down to one. So then it says, where is sine less than 0? So where is sine negative? And so this only happens in these, in the fourth quadrant. So I'm going to construct my triangle in the fourth quadrant. I'm going to use the fact that secant x is 3/2. Secant is hypotenuse over adjacent. So I label that. I'm going to have to do Pythagorean theorem here to find that missing side length. So a squared plus b squared equals c squared. So our hypotenuse is 3 and one of our legs is 2. So b squared equals 5. So b is square root of 5. And since this is in the negative of the y, I have to make that negative. Okay, so we've constructed our triangle, and now I can start finding this information. So for A, it's tangent, which is opposite over adjacent. So that's negative root 5 over 2. No simplifying needs to happen there. Cosine, adjacent over hypotenuse, so 2 over 3. Okay, this notation here, 90 degrees minus x. Well, here's x. So if I think about 90 minus x, what angle would that give me? That would give me this angle right here. This is called the complement. So the complement is, whenever you see that notation, whether it's 90 degrees minus x or pi over 2 minus x, you're using this angle. So instead of reading it from the reference angle, we're going to come here and evaluate cosecant. So cosecant is hypotenuse over opposite. So what's opposite this angle is 2. So 3/2. Okay, so that's example number 4. The last example we're going to do, similar idea. Let's construct this triangle. So before it says if tan theta is negative 3/5 and cosine is less than 0, find the following. Well, before I start finding the following, let's figure out where our triangle is going to fall. Tangent is equal to a negative ratio. That only happens in the second and the fourth. Cosine is also negative because it's less than 0, so it's going to happen here and here. The only place both these happen, the second quadrant. So construct your triangle. Tangent is opposite over adjacent. Well, if I were to place the opposite, that is not negative. So this negative sign can float to the denominator, and that is the leg that needs to be negative. So just adjust your negative where it needs to be so that it matches up correctly with whatever quadrant you're in. Okay, let's do Pythagorean theorem to find the missing side length, which is our hypotenuse. 34 equals c squared, so c is square root of 34. That cannot be simplified, and of course the hypotenuse is always positive. Okay, so according to this triangle, let's go. Cotangent, adjacent over opposite, that is negative 5/3. Sine, opposite over hypotenuse, 3 over square root of 34. Rationalize the denominator. We get 3 square root of 34 over 34. These last two, we see this complement notation again. Again, pi over 2 is 90 degrees, so this is just saying the complement. So we come to this angle, and I'm reading it from here. So cosecant is hypotenuse, which is root 34, over opposite. So opposite that complement is -5. Cosine of the complement, well, cosine is adjacent. Well, the adjacent side to that is 3 over my hypotenuse, which is 34. So I have to rationalize the denominator. And there's our answer. Okay, and that is all for today. So now there is a worksheet you need to go complete, and virtual learners, please submit that. And in-person learners, you can bring that to class tomorrow.